we determined that ABD is 43 degrees because it is an inscribed angle. Notice, inscribed angles, by definition, the word inscribe, in, and scribe means to write, so written on something or inside of something. This angle is on the side of the circle. It's on the actual rim of the circle. That is an inscribed angle. This is an inscribed angle. These are inscribed angles. AEB is not on the side of the circle, therefore it is not inscribed, and it's not in the center, so it's not a central angle. It's just an angle. It's an interior angle. That's all it is. Okay, so that means that this will be 43 degrees because it's half of the subtended arc. What about the measure of arc BC?
It's 60 times 2, right? Because that's the inscribed.
Yes, and the word you guys are looking for is this arc is subtended or intercepted by ABC, or BAC, excuse me, BAC. So the ratio is 1 to 2 again. Very nicely done. So that's 120 degrees. Follow-up question. What's the measure of this angle down here?
60.
Is it 43 or 60? This one down here.
43.
Uh-oh, we're having some... Right, so we're having some discussions because maybe you're thinking that it's the same as this. Let's see here. This angle subtends this arc. So is it 60 or 43?
43.
It is 43 because it's the same as... Right, it's the same. So inscribed angles that subtend the same arc have the same measures. These will be congruent to each other. Similarly, what is this angle right here, CDB, going to be? Because it subtends the same arc that this angle does, so it'll be 60. And if we use a triangle angle sum theorem, I believe these come out to be 77 each because they're vertical angles. All right, folks, looking at those two triangles, what could you make a conjecture?
They're similar. Yeah.
They're similar. They're not congruent because in order to be congruent, the sides would have to be congruent somewhere, right? So these two triangles are similar. That fact we need to list here. So let's say that triangle AEB is similar to triangle. Now we have to be very careful how we name this. So going from A to E is going from the 60 to the 77. Do you see that? Do you see that?
Yes.
So on this triangle, which sides, which vertices do that? Go from 60 to 77. D to E, so we have to go D, E, C. The order is really important here. So these two triangles are similar by angle-angle similarity. And if they're similar, what can we say about their sides? Yes, so that means we can set up a ratio, a proportion of their sides. So that let's go ahead and do that now then. What will 12 compare to? What will the 12 compare to?
4.
You want to think it's the 8, but look carefully. 12 is...
Or 15.25.
You could do that. So Michelle's comparing two legs in one triangle to two legs in the other triangle. That's totally fine to do. Let's do that. Sure, we can do that. 12 compares to 15.25 the same way that
D equals to 8.
DE compares to 8. So you have to be careful because some people are trying to get 12 and 8 to compare to each other directly. They don't, because look where 12 is. It's where the 16 to 77 arc. You see it's an included side here. Well, 16 and 77 are this side on the other triangle. So these two correspond to each other, and these two correspond to each other. Okay, so we can use Michelle's ratio, though. 12 is to 15.25, and we'll put the units there. Okay, so 12 is to 15.25, the same way that DE is to 8. Thank you, ma'am. All right, so from here, we cross multiply, is that correct? So if we do so, I'm going to put an arrow off to the side saying, okay, cross multiply. Cross multiply, so we get 12 times 8 equals 15.25 times DE. And then we solve by dividing both sides by 15.25. So I get 12 times 8 divided by 15.25. That'll give me DE. What is that?
6.29.
Okay, 6.29. Is that what everybody got?
Yes.
Okay, and that's meters. All right, so there's our answer. Awesome. Got that. What I want to point out to you is something that happened along the way that we weren't looking for, but it occurred. Chris, could you pull the screen down for us, because that way everyone can see a little bit better.
So it's forward.
Pull it down, and then on the way up, go slowly on the way back up. There you go. The catch is better on the way back up. Yep. All right. Here's what I want you to notice. Look at these numbers here. Look at these numbers here. You see them? I need your eyes. Ojo, Saki. Okay, we see this? This says 12 times 8 equals 15.25 times DE. That's just from cross multiplying. You're like, what's the big deal? Look at the picture. 12 and 8. 12 times 8 equals 15.25 times DE. You see those pieces? It seems that we have two chords here crossing, correct? DB and CA, they're crossing. And when they cross, these pieces, when we multiply them, are equal to these pieces when we multiply them. So that's true because we have similar triangles we just found out. This is the theorem you're going to do on the next page. Please turn the page. This is our very first theorem.
Is it between series sequence?
It'll be the chord product. It'll be this one. Now, I've been told that my note-taking looks a lot better when I write in cursive.
I can't read cursive.
It does look a lot better and easier.
Here, let me show you what the notes look like, and I'm going to write them down for you again if you'd like. Here's my notes right now. See them so far? Same old, same old?
That's better.
Before you start writing them down, let me show you I got so fussed at by one of the classes. I said, fine, I will write part of it in cursive. And they're like, no, it's going to be worse. And they were all hating on it. And this is what I wrote.
I can't read it.
Yeah.
Right there?
I like it in cursive.
Some of y'all are like, I
have
can't
to,
read
like,
cursive.
point to read your
Product of
print.
the secant
Of the secant.
and its left interior equal.
It would take time though.
Oh, goodness. Now we got a bunch of good readers here.
What is that
Miss
word?
Graham would be very proud. Very
What's
nice,
the
very
last
nice.
thing, that last
That's
word?
squared. And that's exterior. All right, so printed or cursive?
I thought it's interior.
Can I go back and forth? Can I go back and forth?
Yeah.
How about I do the hypothesis, print, and I do the conclusion, cursive?
Sure.
All right, fair enough. Now, I've given you all colored pencils on your tables. You see those? This will help make sense of what we're doing. So, yep, please grab one if you need them.
Only one?
Or grab 3 or 4, yeah. Yeah, definitely. You can also use a highlighter, that also works. So that's how I'm going to do this. I'm going to use a highlighter. Okay, you ready? Here we go. First theorem. We just learned it. I'm going to label the links of each of these chords. I'm going to label them as A, B, C, and D. And then I'm going to highlight each piece so we can see them whenever we do our notes. And your highlighting doesn't have to match mine. The trick here is just be consistent, right? Otherwise, it doesn't serve a purpose. All right. So I'm going to start printing the notes. So the notes say if two chords cross in a circle, then their segments, the product of their segments will be equal. And then I will and here I will freeze the screen so that way you can see what's being. That way I won't cover up as I write. Oh, just make sure. Okay. Okay, so here's our first, unfreeze, come on, there we go. Here's our first theorem. It says, if two chords cross in a circle, then the product of the segments formed are equal to each other. Oh, I'm sorry to hear that. Is it too bright?
No, it's just, he needs the cursive.
The cursive? Oh.
Yeah, I'm not so good at cursive.
Well, it's good to keep in practice because most of our original documents, primary documents, are written in cursive, right?
It's like way worse than like how we are in person.
Well, it's much more stylized, right?
Yeah, it's like a whole bunch of.
Mm-hmm. There's lots. They put a lot of flair into it. Yes, they put a lot of flair into it. That's true.
Decorations or something.
Yes, that's a good way of putting it. That's an excellent way of putting it.
Segments, forms, form aren't equal.
Okay, so I'm getting ready to move on to the next theorem. Are you ready? So the secant property, by the way, all of these theorems are about taking and multiplying things and setting them equal. So the secant product theorem says if you have two secants and they intersect outside of a circle, we listening?
Yes.
So, I'll say this again. If you have two secants that are intersecting on the outside of a circle, I'm going to label this length A, this length B, C, and D. Then, the product of the secant line and its exterior segment, so the product of this entire secant line and the outside part, if we multiply the outside times length of the entire thing, it'll be equal to the other secant's product of the outside times its entire length. So I will write that out as an equation. Hopefully that will make it a little more clear. Oh, slide it over a little bit, like so. Okay, a little bit more. There we go. Yep, it is C times C plus D. I need to do this from a standing position. Sitting position is not working out so well. All right, so here we go. You're still coloring. I'll freeze it so you can color and not get disrupted.
I mean, I think. It was from 2014. Exactly. Trying to confuse everyone.
Okay, and here are the rest of the notes. So that says if two secants cross on a circle's exterior, so they're crossing on the outside of a circle, then the products of each secant and its exterior segment are equal, which means A times A plus B is equal to C times C plus D. So multiply the outside times the entire thing and set them both equal to each other.
Was it interior or exterior?
Exterior.
Oh, let me see.
What's it gonna be? Apostrophe, I can't. Oh. Interior? Everybody does their yeah, I know. Segment.
What you guys talking about?
No, it's earlier. Anyway. This is segment, right? No. Interior? Exterior.
And once you finish, if you're waiting for me to move on, please feel free to work those problems, because I think you can do them without me entirely. Okay, you ready for the next section?
Yes.
All right, I am also ready for you, except for the color part. So here, oops, sorry, here we go. So let's label our stuff again. So this outside will be A, this inside will be B, and this tangent length, we'll call it C. And then, again with the color coding.
Double circle.
So this theorem says, it is the secant product theorem. It's the same theorem. It's the same as the theorem you just looked at, because the last theorem said multiply the outside times the entire thing, correct? That's the secant product theorem. This one's the same thing. Look, outside times the entire thing, right, equals outside, well that's the entire thing, right, times the entire thing, which is the same as the outside, which would be C times C. So it's C squared. Right, so we get the same looking formula. Now just color coordinate so it's easy to see. Maybe I'll actually highlight the C this time. Highlight the B and the A. Okay, once you have those notes written down, please work those three problems. I'll go ahead and read off this theorem to you. You ready? Yes, I'm reading it off. Here we go. It says, first, if a secant and a tangent cross outside of a circle, okay, great, then the product of the secant and its exterior segment, so product of these two things, equal the tangent squared. Period. There we go.